everyone, this is Mrs. J, and today we're going to learn two different methods for dividing polynomials, but first, please pause the video and give the warm-up a try. Okay, go ahead and check your work here. The reason why we're doing this in the warm-up is today we're going to be doing long division with polynomials, which is a very similar process to long division with just normal integers. So you'll see that we start with the number on the inside. So here we do 2 divided by 5. That doesn't work. So we move over, we do 29 divided by 5, which is 5. It goes in 5 times, not evenly, but 5. So you put the result on top. We multiply 5 by 5 to get 25. We subtract and we bring down. Then we start all over again. 45 divided by 5 is 9. 9 times 5 is 45. Subtract, bring down. So that same process is what we're going to carry over when we're using our long division of polynomials. And then notice if you have a remainder at the end, we can write that remainder. We could say the remainder over the divisor. So we can say 59,167 and 2/5. So this is called the quotient, and this is the remainder over the divisor. All right, so now we're going to do the same thing with polynomials. First, I need to set up, so this is going to go inside my little tabletop. So I have 2x squared minus 5x minus 3. One thing I want to point out, we need to make sure that our terms are in descending order and we're not missing any terms. So we have a squared, so we have a 2, 1, and a constant. So we're not missing any in this case. And this is our divisor, so we put that on the outside. So the first thing I'm going to do is I'm going to take this term, 2x squared, and I'm always going to just divide it by the outer term of my divisor. Okay, so I have 2x squared divided by x, which gives me 2x. So I'm going to put that result on top, just like I do with normal long division. Well, then my next step is to multiply and place the result underneath. When you multiply, I'm going to do 2x times the entire divisor. So I do 2x times x, which is 2x squared. And then I do 2x times negative 3, which is negative 6x. Now this next step is where I see the most mistakes. So here we need to be really careful. We know the next step is to subtract. Usually people do fine with that first term, but it's the second, or if there's a third term, where we forget that we're actually subtracting. So I'd like to see you put parentheses around this, polynomial to remind you that you're subtracting the whole thing. So here, 2x squared minus 2x squared is 0. That first column should always cancel out here. Here we have negative 5x minus negative 6x, which is like saying negative 5x plus 6x, which is just x. And then our last step in this round is to bring down the next term. So now I have to do it all over again. I'm going to take the outermost term here and divide it by the outermost term here. X divided by x is 1. So I say plus 1 up top. Then I'm going to multiply 1 to my entire divisor and put it underneath. So here I did 1 times x is x, 1 times negative 3 is negative 3. Put my little parentheses around it, and I subtract. So I'm subtracting everything. X minus x is 0. Negative 3 minus negative 3 is also 0. So when you have no more terms to bring down, that's how you know you're done. So in this case, we have our quotient. Our quotient is 2x plus 1. And in this case, we don't have any remainder. So this is our complete answer. And it actually means that x minus 3 divides in evenly, which means that x minus 3 is actually a factor of my original function. Okay, let's try another one together. So let's do our setup. Here, let's check that the terms are in descending order and that we're not missing any. So we have a 3, a 2, a 1, and a constant. So we're not missing any terms. Then I put my divisor on the outside. So I'm going to start by doing x cubed, and I always just divide it by the outside term of my divisor. X cubed divided by x is x squared. Then I'm going to multiply it. X squared times x is x cubed. X squared times 1 is positive x squared. Then I'm going to subtract. So here, x cubed minus x cubed is 0. Negative x squared minus x squared, this is where I would see a lot of mistakes because a lot of people would just say this is 0. It's negative x squared minus x squared, which is actually negative 2x squared. And then we bring down the next term and we do it again. So I have negative 2x squared divided by x, which is negative 2x. I multiply. Negative 2x times x is negative 2x squared. Negative 2x times 1 is negative 2x. Be careful, we're subtracting everything. Negative 2 minus negative 2 gives me 0x squared. And negative 2x minus negative 2x, so it turns into plus 2x, is also 0. It's okay if a term ends up being 0. But we're not done. We still need to bring this down and see. Well, for our final term, this is just a constant, and I can't do a constant divided by x. So when we've gotten to this point, we know that we can't divide anymore, so we're done. So how do we write our answer? Well, we're going to write this part first, and then our remainder in this case is 8. So we'll say plus 8 over x plus 1, which is our divisor. So I want to make sure we're comfortable with those terms. Again, this is called the quotient. A quotient is the result of a division, and then this is the remainder over the divisor. Okay, so we do quotient plus remainder over divisor. All right, at this point, I'm going to ask you to pause the video and give one of these a try on your own. All right, go ahead and check your work here. I'd say the 2 steps to watch out for would be this step, so that subtraction step here, 3x minus 4x. This division step, negative x divided by x is negative 1. And then again, this subtraction step, negative 11 minus negative 1 is negative 10. So just be very careful when you get to the subtraction step of your process. All right, now let's try another one together. So when I go to set up this problem, you might notice something. This is why we have to check. When we have a 4, a 3, and then a 1, we're missing that x squared term. So when you're missing a term or a constant, you would do the same for a constant, we need a 0 placeholder there. So here's what it looks like. So I have 2x to the 4th plus 3x cubed. Since I don't have an x squared term, I'm going to say plus 0x squared. So that's my placeholder. And then I have plus 5x and then minus 1. If your divisor was missing a placeholder too, you would also include it. But here I have a 2, 1 constant, so my divisor is fine. So always watch out for that placeholder. You'll know if you missed it when you start to do the process of long division. It's just going to look a little weird. Something's not going to line up. So hopefully that will remind you to go back and check to see if you're missing a placeholder. So let's start with our first round of division. 2x to the 4th divided by x squared is 2x squared. And I multiply. 2x squared times x squared is 2x to the 4th. 2x squared times 3x is 6x cubed. 2x squared times 2 is 4x squared. So you see, if I didn't have the placeholder, I would have nothing to line up my x squared term with. Now be very careful with this subtraction step. We have 2 minus 2, so 0x squared. Here we have 3 minus 6, so negative 3x cubed. 0 minus 4, so negative 4x squared, and then bring down the 5x. Let's do it again. I'm going to do negative 3x squared times or divided by x squared, which gives me negative 3x. Negative 3x squared times x squared is negative 3x cubed. Negative 3x times positive 3x is negative 9x squared. Negative 3x times 2 is negative 6x. And we are going to be very careful with our subtraction step. Negative 3 minus negative 3 is 0x cubed. Negative 4 minus negative 9 is positive 5. So 5x squared. Here, 5 minus negative 6 is positive 11x. Now this is kind of a long problem. Okay, last round, one more round. So I have 5x squared divided by x squared, which is just 5. 5 times x squared is 5x squared. 5 times 3x is 15x. 5 times 2 is 10. And we subtract. 5 minus 5, 0x squared. 11 minus 15 is negative 4x. Negative 1 minus 10 is negative 11. Okay, now I just need to write my answer. Maybe I'll write it below. So we have our quotient, which is 2x squared minus 3x plus 5, plus the remainder, negative 4x minus 11, over our divisor, which is x squared plus 3x plus 2. So I know it's kind of a long, ugly answer, but this is our answer. And the more you do these problems, the easier it will get, because it's the same process every time. You just have to take your time, slow down when you get to the subtraction step, and just be very careful looking out for those small mistakes that pop up along the way. All right, here's one more for you to try on your own, so please pause the video. All right, go ahead and check your work here. Hopefully you caught that we need that x cubed 0 placeholder, or else you wouldn't have the right column to line up your x cubed with, so hopefully you would catch it if you missed it. So again, be very careful with the subtraction steps, and here we have our quotient plus the remainder over the divisor. All right, so now we're going to learn another way that we can divide polynomials, which is called synthetic division. And we're going to use this when the divisor is in the form of x minus k. So we'll see the degree of x is just 1. So I know it feels like it's very limited cases, but this will actually be a really, really useful tool for us. And the synthetic division, I think you'll find it's a little bit quicker and easier. So the setup will look weird at first, but once you get used to it, it's pretty easy to use. So first we look at the divisor, and we ask ourselves, okay, if this was the factor, what would the 0 be? So it's always going to be the opposite of what you see here. So the 0 would be a positive 2. So I call this like the box number, and I put it in a little box up in the left corner. Then along this row, I'm going to list the coefficients of each term, also checking to make sure I don't have any missing terms. So my first coefficient is a 1, then a negative 3, negative 7, and a 6. Then leave a space here like a row, and then I do a horizontal line. So the first number is the easiest one to do. We always just drop that number right down. Then I'm going to multiply. I multiply my box number times this number, and I put the result here. So 2 times 1 is 2. And then we add going down. Negative 3 plus 2 is negative 1. Then I'm going to multiply again with my box number. 2 times negative 1 is negative 2. And then I add going down. Negative 9. One more round. 2 times negative 9 is negative 18. And then I add vertically. 6 plus negative 18 is negative 12. So now we need to turn these numbers into our solution. So first we're going to look at the degree of the original problem. The degree of the original problem is 3. When we're dividing by 1 power of x, our answer or our quotient is always going to drop 1 in degree. So if this is a 3, our answer is going to start with an x squared. And then these two terms are going to be the coefficients. This is the constant, and this is the remainder. So what I have left is 1x squared. Remember, this drops down 1 for my answer. And then negative 1x, and then minus 9. That's my constant. And the last box, some people like to draw like a little dotted line here. The last number should always be the remainder. So then I have plus negative 12, the remainder over my divisor, which is x minus 2. And that's how I write my answer. So synthetic division essentially gives us the coefficients or the values that go in our answer. And then we just need to remember to drop our degree down 1, and then we just go in descending order, 2, 1, 0, remainder. All right, let's try another one together. Here I see that my divisor is x minus 3, so the number I'm going to put in my box is positive 3. And then I'm going to list the coefficients I see, noting that I don't have an x term, so I do need a 0 placeholder here, just like with our long division. So I have negative 1x cubed, 4x squared, 0x, and then 9 is my constant. So I drop down my first term, and then I start multiplying and adding. 3 times negative 1 is negative 3. 4 plus negative 3 is 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 9 plus 9 is 18. And again, remember that last term, if you're doing it correctly, should be your remainder. So our original function is x cubed. That's the degree is 3. So for our answer, it's going to be x squared. So negative 1x squared plus 1x. Remember, if the coefficient is 1, we don't usually write it. And then our constant is 3. And then plus the remainder over the divisor. There you go. So you could see synthetic division is just usually a little bit quicker, a little bit easier for people because, again, instead of dividing and then multiplying and subtracting, we're simply just multiplying and adding. So it's a little bit easier for most folks to use, but it can definitely take a little bit of practice to get used to. All right, I have one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check. So make sure in the box you have positive 1, list out your coefficients, and then just multiply and add, multiply, add, multiply, add. And here's our quotient plus remainder over divisor. Okay, here I have one last one for you to try on your own. So again, pause the video. Okay, I think the tricky thing about this one is recognizing you're missing your x squared term, so you need that placeholder here. If you don't have that placeholder, you would not have enough terms to have a squared term, an x term, a constant, and a remainder. So if you are missing, or if you're lacking the number of terms you need for your answer, it's because you forgot a 0 placeholder. All right, that is all for today's video. Thank you so much for watching.